All right, so interpreting linear functions, kind of a review of what we've been doing to kind of wrap up this conversation about linear equations or linear functions. So hopefully you remember the way you find a slope of a line given 2 points on that line. Who we got? Volunteer? Nick?
y2 minus y1 over x2 minus x1.
Good. y2 minus y1 over x2 minus x1. How many people put that? Excellent. Okay, well, let's go ahead and focus in on that. If I'm just a quick review, if I'm given 2 points, okay, 2 coordinates. Cody, give me a number. 3. Jaden, another number? 14. Okay. Maddie, another number? 9. And Jaden Dare, another number? 7. All right. I'm going to make that one negative, make that one negative, and I'm going to make that one negative, and I'm going to make that one negative. Now I have all negative numbers. Okay, that's kind of blurry. All right, so if I'm given those coordinates, and I call this my first coordinate, and this my second coordinate, oops, let's make that an x because it's an x. Okay, so x2 and y2. Okay, if we go through and we make those coordinates, then when we're putting this in, the common mistake that I see students make, it's not because they don't know how to use the formula. They get that. It's that when they're putting these pieces in, they say y2. Well, they put in the -7. They're good there. Then they go y1. Well, y1's -14. If they don't put parentheses there, a lot of times they drop that negative and just put 14. And so it becomes -7 and minus 14. Well, this is -7 minus -14, which makes a plus, right? So that actually is +7 when you're done. -7 plus 14 is 7. And the same thing would happen here. You'd have your x2, which is -9, and you'd have your x1, which is -3, and these two negatives make a positive. So you end up with -6. Okay, -9 plus 3 or -6. So your answer is -7, 6. Okay, so making sure that we're clear that when you're substituting in, you're using those parentheses. That's a common error that I see. It's not that the formula isn't understood. It's just that minor mistakes there. Any questions on that? Okay, then let's go back to standard form. What is standard form? What's the form of standard form? Someone new? Now, how many of you know standard form right now? Raise your hand. Okay. Now, here's what I'm looking for as a teacher. When I ask a question like that, I'm looking for as many hands to go up as possible. If I have 2, that means I really need to spend a lot of time on it. If I spend a lot of time on it in class, that means we have less time to spend on other things in class. How many of you like more time on other things in class? Okay, very good. What is standard form? Wow, look at that. Chantel.
AX plus BY equals C.
Good. AX plus BY equals C. AX plus BY equals C. And what are some rules for standard form? We talked about them the other day. Jody, what's one?
A has to be positive.
A has to be positive. Very good. What's another rule? Cody?
Isn't C can't equal 0?
It's not C can't equal 0. No? Yeah? Gabby?
They must be whole numbers.
They have to be whole numbers. Yeah. Okay. For some of you go, they can't be fractions. Okay. Well, technically a fraction is, or a whole number is a fraction. Okay. It's just a special fraction when the denominator is 1. Okay. They have to be whole numbers. Okay. So mathematically, when we're speaking the mathese, they must be whole numbers. So we should understand what that means now. All right. Very good. Any questions there? Let me give you a quick one to work on. Let's say, for instance, I had 4.7x minus 2y equals 4/3. All right. I want you to write that in standard form. Ready, go. Okay. Time's up on it. Now, let's see how good we are with numeration and number sense, that kind of stuff. Some of us really struggle when we see fractions and decimals. And quite honestly, if I saw this equation, I'd be I'd be having issues because we don't put decimals and fractions usually in the same thing. It's either or. But just for the sake of this problem, if I'm writing this in standard form, I can't have a decimal. It has to be a whole number. Can't have that fraction. It has to be a whole number. How do I get rid of a fraction? Sam? Times it by its reciprocal. Well, that's how you'd move it. Like if you have 4/3 x equals 5, then you'd multiply by the reciprocal to help you solve. But not really how we're going to get rid of that one. Oh, hold on. Someone I haven't called. Forgot. Alec. Multiply it by the denominator. That's how you get rid of a fraction. You multiply everything by the denominator. So I'm going to multiply everything by 3. I'm going to multiply that by 3. I'm going to multiply this term by 3. And I'm going to multiply this term by 3. So 3 times 4 divided by 3, we don't need a calculator for. 3 times 4 divided by 3 is? 4. Okay, 3's cancel. Okay, 2y times 3 is?
6y.
6y. That's y. Okay, and then 4 times 3 is? 12. And then 4 times 0.7 is? 2.1. So 14 and 2, or 12 and 2.1 is?
14.1.
14.1. Did anyone check that on their calculator? Yes, is that right? Mm-hmm. Woo, we did that in our head, man. Some of us. 14.1x. All right, fraction's gone. What's wrong now?
Decimal.
Decimal. How do we get rid of a decimal? Got one person, just Ethan? He's the only one that knows? Ethan, you're our only hope, man.
You can multiply it by 10.
Why 10?
Because like if you change it into a fraction, it'd be 14 and 1/10. And so to get rid of the denominator, or to get rid of the fraction, you multiply by that.
Good. Yeah. Hey, you guys, we really need this decimal to move over one. Good explanation by Ethan. I'm going to explain it a bit different. We need the decimal to move over one. Every time we move a decimal and make the number bigger, you're moving it by a factor of 10. That's why we like the metric system. It's a base 10 system. We love that. It's a lot easier to use than what we use in our country, but that's okay. We're going to still use it. Okay? So 10 times 14.1 is?
141.
141x minus 10 times 6y.
60y.
60y. That's supposed to be a 10 there. Okay. And then 4 times 10? 40. So now we have went from this form up here to standard form down here. All right. Any questions on it? How many think they get how to change standard? All right, let me give you a couple easier ones just really fast, okay? Here we go. Let's do these 3. These ones should seem like a piece of cake compared to what we just did. All right, so let's go ahead and write those in standard form. Look under there and you can explain. You can zoom in.
Like
Here's a zoomer.
this zoomer here.
And then the focuser.
It's like quite messy, but because it's not actually in order. But for this one here, I just subtracted 2x, but then a had to be positive, so I divided by, or multiplied by -1. And then I thought this one was already in standard form, so then I just moved the x around so that it looked prettier. And then that I just moved the 1 over.
Okay, so the first one, y equals 2x plus 7. The problem was the 2x needed to come over.
Yeah.
Okay, and then a became negative. So making sure that right here you guys are flipping your signs. So dividing by -1, that makes that positive, that makes that, or that makes that negative, that positive, and that negative, right?
Yes.
You divided by -1. Oh, this made it positive. That made that negative, and that negative. Okay. Everyone agree right here that this is almost standard form? Yeah, just got to move the x and y's around, put in the correct order. Gabby?
Wait, for the first one, can you just subtract y and subtract 7?
Yeah, you could. If you wanted on this one, if you wanted to move the y over and then move the 7 over, that's fine. It gets you to the same spot, right? Okay. And then this guy here, we just had to move the 1 over. So x plus y equals 1. Well done. How many got it? Okay, very good. So your assignment, thank you, Jordan. Give Jordan a hand. Well done, Jordan. All right. So the assignment you're getting right now, I know not everyone's received it, but when you get it, I want you to cross out the example side, please. Okay? Put a big X through the example side. And then turn over to the mixed side.
Big X through the mixed side. No homework.
All right. So turn it over to the mixed side, and on the mixed side, we're going to work through a couple problems together as a class. Your assignment is the mixed side all, so you're going to be working through problems that we're going to do as a class. So there we go. Those that are circled, 1, 8, 9, 16, 24, and 27, we're going to at least touch on each of those. We may not complete them, the whole thing, but just to make sure we understand what's expected. So I want you to read through each set of directions. We'll start with 1 here in a minute. Go ahead and do what you think you should on 1 after you've read through the other sets as well. It's going to show us number 1 there. You can zoom in if you need to, Nick. It looks pretty good, actually. All right, what'd you do?
Well, I graphed the 2 points, and then I did y2 minus y1 over x2 minus x1 to find the slope. And the slope was -2, so I graphed it.
Okay. So these points right here are the points you plotted, right?
Yeah.
Everyone plot those two? Yeah. How many got more? Like Nick, if he used the slope formula, he could figure it out, but he could also use rise and run, right? Drop down 2 over 1. How many of you got real picky and you started putting other marks here? Okay, and that's okay. When I ask you to plot 2 points, as long as you use a straight edge, I'd be fine if I don't see the other marks. As long as you're not like screaming off in a bad direction there. Okay. That's pretty good. Good job, Nick. Thank you.
Thank you.
Give Nick a hand. He's amazing. All right. Oh, we've got the people who have to be the last clappers. It's still a middle school mentality. However, I'll forgive you since you're only in your first month of 9th grade. Okay? Numbers 8 and 9. Which linear equation, or write the linear equation in standard form. So those of you that are type A'ers out there and you're like, man, I haven't finished through 6 yet. Breathe. It's okay. Go to number 8. You can even leave a spot on your paper for number 7. And then go to number 8 and try to write it in standard form, please. And then try number 9, write it in standard form. In your head, number 8. Jody?
I will volunteer.
You'll volunteer?
I will.
All right, come on up. Do you have number 9 done as well?
Yeah, I don't know if I did it right.
Okay. Well, that gives me something to teach. All right, cool. So you've got 8 and 9.
Yeah.
I could see how some of you might do number 8 in your head, but all right, go ahead and explain number 8 there. Do you want a pen? You can point. Here's a
No, I
point.
just don't remember what I did anymore.
Oh.
Oh, I subtracted y, and then I kept -2, but then I switched all the signs, and so then it was 5x minus y, and then plus 2.
How many got that? 5x minus y equals positive 2. Okay. Very good. Thank you very much. Give her a hand, yeah. Okay, so it's happened twice now where students want to bring the y over. So that's fine. If you do that, if you're going to take this and subtract y over, now you have 5x minus y minus 2 equals 0. And then you bring the 2 over there, which most of you do in one step. So you add 2 and you get 5x minus y equals 2. That's okay if you want to go that route. Okay, if you bring the 5x over, okay, the other process is bring that 5x over. You have -5x plus y equals -2. That's fine. Just remember, divide by -1 and flip every sign. So the common thing is students forget to flip this middle one here. So that becomes 5x minus y equals +2 as well. Okay, either way is fine. All right, this one right here. What do I need to do? Cody.
Subtract -2/7 x from each side.
Okay, so collect the x's on the same side. So I got -2/7 x plus y equals 3. So I subtract 2/7 x equals -3. I'm sorry. Subtract 2/7 x from both sides. Kobe.
Multiply all by 7.
Yeah, multiply all by 7 to get rid of that. What's the other problem right now? Claudia? A is negative. So I can think of this. I can bring that negative down here if I want. The negative could be attached anywhere on this fraction. So rather than just multiplying by 7, if I multiply by -7, everything, the negative disappears and the fraction will disappear. Okay, so when I multiply this part by -7, it just cancels that. The negative times negative is positive, and the 7's cancel, so I'm left with 2x. And I multiply this by -7, which I didn't give myself a lot of room, but times -7, that gives me -7y. And multiply that by -7, that gives me positive 21. 2x minus 7y equals 21. Okay, so if you go by -7, that's good. If you go by 7 and then divide out the negative, you could do that as well. Okay. Questions there? Hopefully we're getting a little better at those. All right, tell your neighbor how you're going to solve number 16. Take a look at 16 and the instructions, how you're going to solve it. Comparing from 16, where we found m and b, we used our m to find our b, wrote our equation. Looking at number 24, how is that one different and how is it the same? Write that equation of a line. Okay, Nick, how's it the same or different?
It's different because it doesn't give you any points.
Okay, it doesn't outwardly give you any points, right? How else is it different? Cody?
Well, it gives you the intercepts, which technically are points.
Okay, it does give you intercepts, which technically can be made into points, right? So the x-intercept is what coordinate?
4, 0.
Yeah, it's 4, 0. It's when y is 0. And the y-intercept is what coordinate?
0, 5.
0, 5. So you're actually given two coordinates there, right? So if I'm looking at that, the y-intercept of 5 is 0, 5. The ordered pair is 0, 5. The x-intercept of 4 is the ordered pair 4, 0. The other thing that the y-intercept is, we have a special name for it. We call it b. So we know b. B is 5. We need to find m to write our equation. I'm going to leave that to you. You know how to do that. But the last problem, so that was writing equations of line. The last problem I want to talk to you about is number 27, the dreaded story problem. Okay? It's around Halloween right now, so story problems can scare us, but it's okay. If you think of them as a story, and this one's a good story because it has the year 1993 in it. Amazing year. Anyone know why? No, it's not my birthday. It would be great if I was born in 93. Man, not too bad, right? Okay, like 21 right now. With not so much since I have a 14-year-old, but
You'd be like,
okay.
You'd be like 17, 20.
Huh? All right, 21.
You'd be 21, yeah.
Yeah, 21. Thank you. Okay. What else? 93. I'm almost 40. That's your hint. Yes, I graduated in 93, dude. That's awesome. All right, we're the class of 93. Okay. Huh? Who was born in 93? Jocelyn?
You're 21?
All right. Jocelyn, we're in advanced math right now. Okay? You were not born in 93. I'm pretty sure. All right.
You've been in 9th grade for a while.
Number 27. Here we go. Hey, right here now. While prices for color inkjet printers dropped from 93 to 96, revenue from color inkjet printers rose from 739 million to 2.9 billion. Using years past 93 for X. So in other words, when they say stuff like that, a lot of times what we think of is time began in 1993. Like year 0 is 1993. Okay? So a lot of times when we're dealing with years, we do that. We say, okay, using years past 93, that means time began that year. So in 94, we're at what year? 1. 95, we're at year
2.
And 96, we're at year 3. Okay? So using years past 93 for X, so that also tells us that time is equal to?
Can't see.
Thank you. Time is equal to?
3 years?
Nope. Yeah, it's our X variable. Time is almost always your X variable. Time is almost always your independent. I mean, almost every single time, time is your independent. Because time is independent. It doesn't depend on anything. It's just going. I'm not going to go into when it isn't. Okay? But time is almost always your independent. Okay. Using years past 93 for X and millions of dollars in revenue for Y. So what's Y?
Million revenue.
Good. Revenue. Thank you again. Revenue in what?
In millions.
In millions. Now, some of you have missed this on your test. In millions of dollars. Some of you missed a point for not telling me what type of currency you're measuring in. Millions could be, you could be talking about euros, pesos.
Puppies.
Well, it's revenue. Well, yeah, maybe millions of puppies. I don't know if I want that currency. Okay. All right. So millions of dollars in revenue for I. Write your linear equation to model the revenue. Okay. Well, in order to write a linear equation, they tell you it's linear, which means it's in the form of
Y equals mx plus b.
Y equals mx plus b. I want you to talk with your neighbor, see if you can figure out how to find the pieces you need to write that equation. You get 1 minute. Hey, it's funny when I walk around as a teacher to hear conversations. Sometimes it's like in-depth, good conversation about it. Sometimes it's like, oh, dude, the teacher's coming, so let's pretend we're talking, and we just talk about random things that sound like math until you walk by, and you're like, woohoo, yeah, dude. Okay? Sometimes you don't even care. You're just like sitting there like, man, there's like a roof on this house, on this place. So you're like looking around and checking things out. Okay? It's good to hear you actually talking in context of the problem. As much as you may not think, I do listen the majority of the time as I'm walking around. Sometimes I'm looking over your shoulder. I'm not trying to be a creeper. I'm just trying to see what you're writing. Okay? In this case, we need to find two things for a linear equation. What are those two things? I heard it out there. What's one? Darren, your hand up? I saw your finger up, like disco. Oh, okay. What's one? Slope. You have to find M, and we have to find everyone?
B.
B. Hopefully that's obvious. Now, they tell us, well, they don't tell us either, do they? Or do they?
They tell us B.
Do they tell us B? What's B?
Well, B would be 0 because
So right here? You're right, Claudia. Claudia's right. They tell us B. But we have to figure out, like, that's a point then, right?
yeah.
That's an x coordinate. Years are x. So we're given a coordinate here. We're given a coordinate 0. 0 what?
0.
Not 0, 0. What's our y stand for?
Revenue.
Okay, now, hold on. Here's when I look out there, I see half students, like, at least staring up here, either focused or pretending they're focused. And then I see some that are like, okay, they're like looking around and I don't know what they're doing. Dude, pay attention. What is our y stand for?
Revenue.
Yeah, y is revenue. The revenue in 93 is 739 million. Now, do I need to put the million?
No.
No, because we're defining y in terms of millions. Dude, that's a coordinate. As Claudia said, that's your y-intercept. Why? Because x is 0 there. That's good. We like that. We know b. How many knew that? Okay, now you do, yeah. Do we know another point? Because if we know another point, what can we find?
The slope.
Slope, which is what we need. Everyone come up with that other point. You get 10 seconds.
Would be 3, 0.
Okay, time's up. What's the x value? 3. What's the y?
2,900.
Good. It's 2.9 billion. 1,000 million is 1 billion. So 2.9 times 1,000 is 2,900. Just so you know, by the way, a million is a trillion. And our country's 17.6 or so million dollars in debt. That's 17 million. That's a lot, dude. That's like 17 million millionaires donating $1 million. Then we'd almost be out of debt. We'd still have that pesky 0.6 trillion. Okay? Yeah, dude. Okay? Just saying. You guys will be voting in a few years. Figure out which politicians are going to get us out, help us get out of debt. And vote for them. I'm not going to tell you which way to vote. I don't do that. But seriously, pay attention. It's going to be the next set of workers that help pay for that debt. Anyone know any of those workers?
Us.
Yeah, look to your left and right, man. That's you.
Pickles.
I know. All right. Hey, you guys should be able to finish that now. Claudia.